What's up everybody, welcome back. So excited to start a new chapter in our multiplayer AI series, and we're going to be looking at a guarding AI for this one. So in this little intro I'll be explaining what we're going to make, what kind of features we'll be using, and some of the design choices that I made. So I definitely encourage you not to skip this little intro, but just watch it. It's only going to be like 1 or 2 minutes, so it shouldn't be too bad. And then at least you know what we're up to. So in the previous chapter, we did a little basic turret AI, and if you missed that and you're a true beginner for AI, you might want to start with this one. It's a little bit easier because the turret can't move, obviously, it can only aim and fire, but we are using some semi-advanced techniques like the perception and a blackboard and a behavior tree, target prediction, so stuff like that. So if you want to start a little bit easier, make sure to check out this tutorial series. And for now, let's have a look at our guarding AI. So here we are in a quick example project. So first of all, the reason why I picked the UE for mannequin and the animations that we're using. So I wanted to make sure that this character, and I'm talking about the AI character and not the player character, is going to be using an AimOffset, is able to crouch, and also is using turn in place animations. And this animation starter pack from Epic that we're going to be using has all of these animations in it, except for the turn in place animations, but I'll get back to that later. And because this is actually on the UE4 skeleton, and the project comes with retargeters to easily retarget to a UE5 skeleton or any other skeleton that you might have, this felt like a pretty good solid setup. And since this is an AI tutorial and not an animation tutorial, I didn't want to spend 2 or 3 episodes of about an hour actually setting up retargeting and all of that stuff. So to make sure that the focus is on the actual AI part and not the animation part, this is what I picked. But on the other hand, obviously animations are pretty important, so I did wanted to make sure it looked kind of decent. So over here I disabled the perception and the awareness and things like that for the AI, so it's only aiming at me right now, and you can see we have an aim offset that goes for the yaw of the character and the pitch. So he can aim up and down and from left to right, and if the aim offset reaches a certain point, then he'll be kicking in a turn in place animation. So for the turn in place animations, we'll get back to that a little bit later, but these use animation curves, so they have a minimum amount of foot sliding, and they will adjust to the needed rotation delta. So it's a fairly decent setup for the turn in place animations as well. So that's a little bit explanation about the design choices for the AI character. You can see the player character also is holding a weapon and has a hip fire animation, but that's really not too important. So I can fire around the corner and things like that. So this is definitely not focused on the AI, the animation part of the player. The animation part of the AI is included, and we'll definitely be looking at that, but for the player animations, this is just a placeholder since I'll be expecting you to migrate this into your own project. Okay, so that was the animation part. Now let's take a look at the perception and behavior for a little bit. So let's quickly take a look at the project and the setup for the project. So for the weapons, we're going to be using data assets. So that's something we'll be including in here as well. And then we'll simply have an exposed variable on the AI where we can select a weapon for the AI to use. So that will be included in here as well with actual data asset setup. Then we're also going to be using a behavior tree with a blackboard and also some EQS in here. And let me show you a little bit of the behavior. If I quickly hook up everything that I disconnected to make sure that I can show the turn in place animations. So over here, and then I should be going in here to hook up the perception. And I want to clear the focus. So now we should be good to go. So right now I'm in game and the AI has the perception enabled. So if I get to a certain range, he will see me and the bar will start filling up. And if I start hiding, the bar depletes. So if the AI actually sees me, he will go and investigate that location. So he will start moving towards here. You will see the exclamation point above its head. And then using a little bit of simple EQS, he will do a semi-search of the location. And if he doesn't find the player, he will return to his original location. So that's what's happening over here. And as you can see, right now he is returning. And he's using all of the proper turn-in-place animations and things like that. And we'll also have a hearing perception, although if I fire at this location, he might investigate the wrong location, but that'll be fixed, so don't worry about that. So as you can see, if I fire my weapon inside of a certain range, the AI will also start exploring that location, and if he can't find anything, return to his original location. So that's pretty much the basic behavior, and then obviously we can trigger actual combat as well, and then we will simply start fighting and it's on. So there's no combat in this little demo, but rest assured we will be able to fight them. So this is pretty much the setup that we're going to be using, and I think it's time to just start working on this. So if you're interested in the actual project files, you can become a member of the YouTube channel or a Patreon, and then I'll make sure to upload these project files to the Discord, so you'll have access to premium channels in the Discord with downloads for this project as well. So yeah, let's start building our guard AI. One final quick note, all of this obviously works in multiplayer as well. So on the right side you will have the client, and on the left side you will have the server, and as you can see everything replicates. So the turn-in-place animations, the AimOffset, all that kind of stuff actually works for the client as well, as you can see over here. So it's going to be a multiplayer AI. Okay, let's dive into it. Okay, so here we are in the project. I have created a default third-person project. You can use first-person, third-person, whatever you prefer. That doesn't really matter. So this is just a default third-person project. No starter content, nothing added. There's nothing changed in here, and this is where we're going to start. So in this first part, we are going to set up the character for the AI with the animation blueprint. So no actual behavior stuff in here yet, but obviously we need something to work with, so we need to start building the character first. Let's take a look at the assets that we're going to use. So from the Epic Games launcher, first of all, you want to get the animation starter pack over here. So this is an Epic pack, and it contains about 60 animations with Hip Fire, aiming, ADS, or sorry, Hip Fire and aiming, and then aim offsets, crouching, all that kind of stuff. So we're going to add this to our project. So click the add to project and make sure you select your correct project over here and simply add it. So I'm using Unreal Engine 5.2. And then we also want to get some weapons that we can work with. So I'm using the military weapons dark pack over here. So you can get it from the marketplace as well. It's a free pack, and it's not available for 5.2, but that's not an issue. So we can simply add it to a project and then click the little show all projects over here. So these are just models and animations, so it doesn't really matter in this case. And then we can select our guard project and make sure that we select the highest engine version available over here, and then simply add it to the project. So then we have the weapons and most of the animations in place. There is one little thing that we need to quote unquote fix. We need some turn in place animations, and those are not included in the animation starter pack. So I'll be using the turn in place animations from the Lyra starter game. And I realize it's a pretty chunky download just for 4 animations, but those animations just fit the character pretty good, and they come with pre-set up curves as well, so that's a little bit easier in this case. A little side note, if you want to migrate them, make sure you grab the Libra project that has the same engine version as the project that you're using to avoid getting any issues. So I'm simply going to open the Lyra game in Unreal Engine 5.2. So this is the Lyra starter project from Epic, the example project that you can download for free from the marketplace as well. So it's actually loading on my other monitor, so give me a few seconds. There we go. So this is the Lyra game, and in here we want to go to the characters folder and then go to heroes, mannequin, and then we want to go to animations. Inside of the animations we want to go to locomotion, and then I'm going to grab the pistol animations. So let's expand this a little bit. So we want to grab all of the turn in place animations in here. So I'm simply going to look for turn, and then I want to get the 90 left, the 180 left, 90 right, 180 right. And we're also going to grab the ones for the crouching. And actually these are the female ones, and the crouching only have the male ones. So let's make sure that we grab all of the male ones, and that should be better. So we have 4 crouching and 4 standing turn in place animations. I'm going to right click, go to asset actions, and then migrate. So now it wants to migrate pretty much the entire Lyra project. So that's not what we want. We're going to disable everything and then only enable the animations that we actually want. So only the 8 animation files in here you want to tick, and the rest is going to be unticked. Click OK and migrate them into your new project. So that should be over here, and then select your content folder and accept it. So now we are good to go asset wise, and we have all of the assets set up inside of our project over here. So first of all, let's take a look at the turn in place animations. Those are in the character folder over here: heroes, mannequin, animations, locomotion, pistol. So for all of these, we want to replace the skeleton, and I'm not sure if we can do them all at once. So let's give it a go. Yeah, we can. So I've selected all of them, right click, and then go to replace skeleton over here. And now we want to select the skeleton from the actual animation starter pack. So that should be this one, UE4 mannequin skeleton. And as you can see in the path, it says the animation starter pack one. So select this skeleton and hit OK. So now they are usable for my other character, and I'm simply going to copy them into the animation starter pack folder, or not copy but move actually. So we have all of the animations in the same folder, and we can get rid of the heroes folder over here because it's empty right now. Okay, so we have the turn in place animations in here, and let's make sure that we check them out quickly. So over here, turn left, for example, if we open this one up. So this is pretty important. We want to make sure that if we disable the all curves over here, then it will actually still show the remaining turn yaw curve. So if it doesn't show the curve when you disable this button, that means the replacing of the skeleton didn't go correctly, and you won't be able to access this curve in the animation blueprint. So then you will run into problems later. So make sure if the animation is playing, this curve actually updates over here if you have the all curves disabled. So that's pretty important. Now we want to make sure that we shorten these turn in place animations for a little bit. So as you can see, all of the turning happens here, and this part is, well, pretty much no animation. So over here, we're simply going to blend it back into the previous pose. So for the turn 90 animations, I'm going to remove all of the frames after frame 19. So simply right click on top of here and then remove frame 20 to 52. So that's good to go. And then we want to do the same thing for the turn right 90 animation. So again, I'm going to go to frame 19, right click, and I want to remove frame 20. over here, so 20 to 51. And then for the turn right and left 180, we also want to shorten those a little bit. So for the left one, I've removed frame 28 until the end. So over here, 28 till 61. And for the turn right 180, I've removed frame 30 plus. So let's go over here, frame 30, and remove 31 to 56. So that should be good to go. Let's have a look. So we also need to have an aim offset. So let's take a look at creating our aim offset in here. Let's save these animations. So inside this animation folder at the top, we have two animation files, AimSpace Hip and AimSpace Iron Sights. So first of all, we're just going to look at the Hip AimSpace. We're also going to get back to the crouching turn in place animations later. So over here, you can see all of the, boundaries, I guess, for the aim offset. So all of the maximum offsets. But we need to make sure that we put these in separate animations so we can make them additive and we can turn this into an aim offset. So what I'm going to do is create a new folder inside here and call this aim offset. So I'm going to grab the AimSpace Hip and then copy it in here, not move it. So make sure you keep an original copy of this file. Then in here, I'm going to duplicate this a bunch of times. So duplicate it. And the first thing I'm going to do is rename it. So AimOffset Hip. And then we want to make the different animations. So we're going to start with center, center. And then we're going to duplicate the original animation again and call this AimOffset Hip Center Down. And then we also need a center up. So duplicate it again and then AimOffset Hip Center up. So let's take a look at setting up these three first. So I'm going to open center, center, and then we simply want to aim forward. So we want to be at frame 0 over here. Then I'm going to right click at the top again and remove frame 1 to 87. So we're going to end up with a one frame animation that simply is frozen like it should. And then we need to set up the additive animation type. So in the left on the asset details, you want to go to additive settings over here and change it to mesh space additive. And then we need to set up a frame from animation. So we want to go to, let me see, selected animation frame. So this one. And then the base animation is going to be the idle hip. So we want to grab idle hip. Idle rifle hip, this one. And with the animation selected, I'm going to browse to it in my content browser. So it will be highlighted over here, so I don't have to look for it every time I want to assign it. And then for the reference frame index, we simply keep it to 0. So this is the center, center animation for the aim offset. We're going to go to center down next. Now we want to move it to the part where we're aiming down in front of us. So that's frame 20 over here. Then we're going to remove frame 0 to 19. And then again, right click and remove the other frames. So frame 1 to 86. We'll end up with the one frame animation. And we need to set the additive to mesh space again. Base pose is going to be selected animation frame. And then I'm simply going to hit the little arrow. So it selects the rifle hip animation. And the index is 0. So that's center down, and the third one is center up. So let's do that one as well at frame number 10. So remove frame 0 to 9, and then remove the other frames as well. And set up the animation, additive type, mesh space, selected animation frame, and hit the little arrow to select idle rifle hip. So those are the center, center up and center down animations. Now we're going to use a 3D aim offset. So we also want to make these animations for left and right. So you want to make left center, left down, left up, and then right center, right down, and right up in the exact same way that I just showed you. So if I'm going to do that off video because it's probably going to be a long video and I don't want to extend it any further than needed. So I'll be back in a sec. So I'm back and I have created all of the AimOffset animations, so you should have 9 of them right now. Make sure you have all of the mesh space additive settings set up correctly, and then we are good to go to continue. So we're going to right click, go to animation, and we're going to create an AimOffset. So select that one. We need to select the skeleton, and we want to select the animation starter pack UE4 mannequin skeleton. So select that one. And let's call this my AimOffset AI guard hip, for example. And let's open it up. So first of all, we need to set up the axis on the left side. So let's expand the horizontal axis, and we're going to call this the yaw. And then that goes from -90 to 90. And for the vertical axis, we're going to call this our pitch. And it also goes from -90 to 90. So now we need to set up the animations down here in this little graph. So let's start with the center animation that goes in the center. So where we have 0 yaw and 0 pitch. So let's zero it out over here. Then we can grab center down and make sure that it's at the center in the middle over here. So we're going to set the yaw to 0 again, pitch -90. And then center up. So obviously that goes over here, and then we set the yaw to 0 and the pitch is 90. And do the same thing for the left and the right animations. So we want to put left center on the left side over here, yaw -90, and then the pitch is going to be 0. Left down, and we can simply drag it into the corner and the values should be good. And for left up, do the same thing. And we also want to put in the right ones. So we have right center. Let's zero out the pitch on this one. And then dragging right down and right up. There we go. So now if we hold Control and move the little preview icon around, you can see the AimOffset is working. So that's what we're going to be using in our animation blueprint a little bit later. So save it and close it down. Now let's go back to the animation folder over here, and we want to take a quick look at the BlendSpaces as well. So first of all, let's open our BlendSpace jog. And if we go in here and look at the actual speed 0, it has no idle animation in here, but it's actually using the run animation. So we're going to change that up. Let's look for the idle hip animations. And I'm simply going to grab idle rifle hip and plug that into all of the lower ones. So I need to delete the existing animations in here. So you can select them and simply hit delete to remove them. And then at the center, we're going to put the idle hip, and also at the bottom right and at the bottom left over here. So now we actually don't move if we have speed 0. And I also want to add the walking animations inside of this blend space. So let's look for walk, and we actually have walking with the rifle for iron sights. So we're going to grab walk forward iron sights, and I'm going to put this one over here. So that's going to be at speed. Well, let's make speed 140. And then direction 0 is the forward movement. So backwards rifle goes all the way to the left. And then let's make sure we set the speed to 140 as well. And then drag in backwards again and also put it all the way at the right over here. So again, speed is going to be 140. And then we have the left one, so that goes over here, right in between center and right, left, obviously. And we want to select this one and also make sure that we have the speed set to 140 and the direction should be -90. And then for the rifle right, put it at the other side over here. And this is going to be direction 90, speed 140. So we have our blend space set up as well. That's good to go. Now also we want to take a look at the crouching blend space. So let's open this one up as well. And as you can see, it has the same quote unquote issue. It's not really an issue, but it's just not the way we want it. So we need to replace the lower animations over here with the idle animations again. So I'm removing all the lower ones. And then let's look for crouch. So these are the crouch hip fire animations. So we want to get the crouch idle rifle hip, and then simply let's plug it in at the center and then at the bottom right and the bottom left. And we should be good to go. So that's the crouch hip fire blend space. And now we also want to grab the blend space and duplicate it. So we're going to do crouch walk and then iron sights. So let's call this iron, open it up. And in here we can simply remove all of the existing animations. So if we go to the left side, blend samples, hit the little trash bin, and all of the animations are gone. And then we can look for the crouching, and this time we want to grab the crouching iron sights. So let's grab idle and plug it in at the bottom, center, bottom right and bottom left. And then we also want to grab the actual animations over here. So we have crouch walk backwards, iron sights. We're going to put that at the top right and the top left. Forward iron sights is going to be in the center at the top over here. So that's going to be direction 0. The left one goes on the left side, and that's going to be direction -90. And the right one goes on the right side. Oh, I accidentally opened it up. So let's go back to the blend space and then grab the animation and drag it in here. And this is going to be direction 90. Okay, so now we have the blend spaces set up as well. So let me rename this to get rid of the little 1 at the end. There we go. Okay, blend spaces, aim offsets are good to go. The last thing we want to do is take a look at the fire animations. So let's look for the fire animations in here. First of all, we're only going to take a look at the rifle firing animations. We'll get back to the rest later. So let's open fire rifle hip. And we want to turn this into an additive animation. So on the left side over here, we want to go to the additive animation type, and we're going to turn this into mesh space again. Then we're going to select a frame from this animation. So we can select the lower one over here, and then the reference frame index is simply going to be 0. So that's the hip fire, and let's grab the rifle iron sights fire as well, and we want to do the same thing. So again, select mesh space additive, then the base pose type is going to be a frame from this animation, and the reference frame is going to be 0. Save it and close it down. So at this point we have all of our animations and blend spaces and stuff like that good to go, and we can actually start setting up the blueprint for the character and the animation blueprint. So let's start working on that. So all of the boring animation stuff done, and we can finally start building a few blueprints. So first of all, I'm going to create a new folder and call this my game dev raw AI guard. And in here, I'm going to create the blueprints. So we're going to set up the animation blueprint first, but we need a reference to our character blueprint in there. So first of all, let's create a character blueprint. So right click, select the blueprint class, and we want to select a character over here. So this is going to be my blueprint, game dev raw guard. And we need to open it up. I want to set up one little thing in the event graph before we continue. So let's go to the event graph, and we need to use event tick over here. So we're going to use the base aim rotation to set the aim offset, and our default pitch is replicated, but if we look at the base aim rotation yaw, that's not actually replicated for clients. So unfortunately we need to replicate that ourselves, and we're going to do that on tick. So we're going to grab our base aim rotation, right click in an empty spot and look for get base aim rotation. And we only want the yaw from here. So we're going to right click and split the struct pin. Then we're going to drag off the yaw and promote it to a variable. So this is going to be my character aim yaw. And hook it up to tick over here. So for the character aim yaw, we want to set the replication on the right side to replicate it. So because this is a replicated variable, the server needs to set it. So we're going to make sure that the clients don't run event tick, because there's no need for them to do so. So we're going to create event begin play as well. And we're going to grab a branch at the beginning over here to check if we are the server instance. So let's look for is server. And if this is false, then we're going to disable tick. So we're going to drag off here and then set actor tick enabled. And for clients, so if this is false, we're going to disable tick. So that's all we're going to do in the character blueprint for now. And now we can access the AimYaw from our animation blueprint. So first we can set up the entire animation blueprint and have that out of the way. So let's right click, go to animation, and we want to create an animation blueprint. We need to select the skeleton. So that's going to be the one from the animation starter pack, the UE4 mannequin skeleton, and click create. So let's call this my animation blueprint GDR card. Well, we can really. And let's open it up. So in here, we're going to start at the event graph. And the first thing is going to be pretty simple. We need to get a reference to our character in here. So we're simply going to grab our blueprint. No, we don't want to grab update animation, sorry. So we're gonna go to functions, override, and we want to override blueprint initialize animation. So this function only fires once if the actual animation blueprint is initialized, and this fires every update. So if we try get pawn owner, we're gonna drag off here and we're gonna cast it to our character blueprint, so the BP GDR card. And then we're going to promote this to a variable so we can access it later. So promote to variable, and this is my BP GDR guard. There we go. So that's all we really need to do in here. Now we're going to use our function thread save update animation to actually populate values from the character. So we're not going to use the event graph for that. In Unreal Engine 5, they have a new function over here. So if we go to override, blueprint, thread save, update animation, if you can use this, then this will be a bit better for performance reasons. So to simply populate variables, we can use this one. And we need a few variables to drive our AimOffsets, BlendSpaces, and that kind of stuff. So we're going to create a new variable first, and the first one is going to be our speed. And that's a float. Then we also need a direction to plug in our blend space. So let's create a second float and call this direction. And we need the values to drive our aim offsets. So that's the character aim pitch and the character aim yaw. So let's create floats for those as well. Character aim pitch. And then also the character aim yaw. Like so. So over here, blueprint thread save update animation, we're going to set the speed first. So let's drag in a setter for the speed. And to actually get this value, we want to use the property axis system that they built in. So first I'm going to drag off the speed, and I want to get the vector length. So first of all, let's get that node, vector length over here. This returns a vector, and for the vector we want to plug in the velocity of the character, so we can drag off here and look for property axis. Select this one, and then if you click the bind button, you can go to the character, because that variable that we created over here will be accessible from the property axis. And then with the character highlighted, we can grab our velocity from the list over here. So simply do get velocity. Select that one, and this will populate the variable for us. So we need to do the same thing for the direction. So we're going to grab the direction, plug in a setter over here. And to get the direction, we need to right click in an empty spot and look for calculate direction, this node. And there's actually two of the nodes, and I usually grab the one that has a target as the animation instance, and the other one has the Kismet animation library. I don't really think there's a difference, but I usually grab the green one over here. So we need to plug in the velocity, and we just got it over here. So we can simply plug it in like so. And we also need to get the base rotation, and for this we're going to use the actor rotation. So we can simply drag off and look for property axis again. we're going to bind it to our guard, and then from the guard we want to get the actor rotation over here. Simply select it, and that will make the value populate. So the next thing is the aim pitch, if we actually hook this up, so make sure you plug it in over here as well. For the aim pitch, we can drag in a setter again, and this time we want to get the base aim rotation of the character, but we only want the the pitch, and we want to normalize it. So first I'm going to look for a normalize axis node and plug that in over here. Then we want to get the actual base aim rotation. So if we right click in an empty spot, look for property axis again. And we're going to go to our guard, and this time we want to get our base aim rotation. So let's look for that in the list over here. Base rotation offset, control rotation. So over here, base aim rotation, simply select this one. Then we can drag off here and break the rotator. So we're only going to use the pitch, and we simply want to plug it into the normalize axis node. So what this one does is clamp the axis to a range from -180 to 180. So instead of using 360, for example, so this will make the actual value usable in our AimOffsets and BlendSpaces. So that's a very useful node in this case. And so the base aim rotation pitch replicates. So we can simply grab this, and this will work for host and clients. But as I mentioned previously, the yaw does not replicate for some reason. So we need to set that up a little bit differently. First of all, let's grab a setter for the aim yaw and plug it in here. Then we want to get the value that we actually replicated on our character blueprint. So we can right click and go to the property axis system again. We're going to look for our guard, and this time we want to go all the way down. So over here are the properties on the character, and in here is the actual property that we created. So the character aim yaw, the replicated variable, select this one. And we actually need to do a small calculation in here. So we're going to drag off the aim yaw, and we're going to subtract another float. And we're going to actually subtract the base aim the actor rotation of the character. So if we go to the beginning, we have the get actor rotation node over here. We can drag off and break the rotator. So we want to grab the yaw and plug that into the minus node. So we're going to subtract the actor yaw from the base aim yaw. And then we want to grab a normalize axis node again. So drag off the result in here, look for normalize axis, and we can plug the result into the character aim yaw. So that's what we can use for our aim offset. Okay, so this part should be good to go. Now, the next thing I want to do is take a look at the last part of the event graph, and that's mainly used to drive our turn in place animations. So before we continue, I need to be honest about the turn in place animations. I didn't come up with this part myself. So animation blueprints and that stuff can be a whole career on its own. There's so much that changed in the recent UE5 especially. There's so much things that you can do in here if you want to make a decent and advanced animation blueprint. That'll definitely take some time to master. So it's not something I'm interested in learning or wanted to do myself. I simply want to have a decent setup for this tutorial for the character. But I'm not going to go into it too much on how it works and stuff like that, because it's not something I made myself, so I feel it's not the right thing to do. So I'm going to link the original tutorial in the description. It's from UE4 tutorials on YouTube. It's actually a really great video. It shows you a lot more stuff about this actual turn in place animation setup. So it explains how it works. It will show you how to extract root motion from existing animations if you don't have curves set up already. So it goes much deeper into the actual subject. I'm simply using this turn in place part, and I've adjusted it a little bit so it suits our project, and it also works in multiplayer. So I made a few small adjustments in here, but in general, it's this turn in place animation setup that I'll be using. And if you want to know more about this turn in place animation setup, make sure to check out this tutorial, and I'll link it in the description as well. Back in the event graph, let's set up our turn in place stuff, and we need a few variables for those. So we're not going to be using montages, but we're going to use a state machine and play the animations in there. So we need a bunch of variables to drive that. So first of all, we're going to create a bool is turning left. Make sure it's a bool. And then we need a second one is turning right. And we're going to use a third bool, and that's going to be called use turn 180. No. Use turn 180 animation. So we have 3 booleans, and we also need 3 floats. So the first one is going to be the yaw delta. Turn it back into a float. The second one we need is our current yaw. Again, that's a float. And the last one is our target yaw, and that's a float as well. So for this, we are going to be using the blueprint update animation. And the first thing we want to do in here is make sure that our guard reference is valid. So let's drag in our guard and do an is valid check and hook it up. So that's a start. Then we need a branch in here to check if we're not already turning or not. So we're going to grab a branch, and we're going to grab is turning left and is turning right. And we want to make sure that we're not doing any of those. So we're going to look for a not boolean. Hook them up over here, and then we're going to look for an end node. So both of them need to be false if we want this branch to return true. So let's do the true pin first. We're going to add a sequence at the start over here. So look for a sequence node. And the first thing we want to do in this sequence is set our yaw delta. So we're simply going to grab a setter for the yaw delta, plug it in, and we can simply hook up our character aim yaw over here. So the reason we're storing it in a separate variable is because we don't want it to change anymore, and we're updating this on each update of the animation blueprint. So we have the yaw delta stored. Then we're going to check if we're moving or not. So we only want to play turn in place animations if we're standing still. So we're going to grab a second branch, grab the speed, and simply do an equal to 0. Plug it in over here. So if this is true, we can perform a turn in place animation, and we want to set a certain boundary where the turn in place animation kicks in. So we're going to grab a second branch over here, and we're going to check our yaw delta. So if our yaw delta is greater than 45 degrees, so I'm going to look for greater than or equal to, and then simply type in 45 degrees. Then I'm going to play a turn in place animation to turn right. So if this is true, we're going to grab our is turning right and set that boolean to true. And to make sure that if we come from turning left, we want to set this one back to false. So we're going to grab is turning left and set this one to false over here. So if this returns false, we might be able to turn left. So we're going to grab a second branch, plug it into the false pin. And for this one, we want to check if our yaw delta is less than or equal to minus 45. And if that's true, we can play a left turn in place animation. So we can grab these 2 booleans again and hook them up to the true pin over here. And this time we want to set turning right to false and turning left to true. Now if this returns false over here, we're simply going to grab both of the bools and set them back to false, just as a little failsafe. So make sure both of them are false over here. And we're also going to hook up the false pin for the speed is equal to 0 over here to the false setters for both of the booleans. So left and right are set back to false. One last thing we need to do over here is grab our yaw delta again. And this time we want to get the absolute value. So look for absolute float. And this will simply turn a negative value into a positive one. And then we can drag off here and check if it's greater than a certain threshold. So I'm going to say greater than or equal to. And if this is greater than 110 degrees, then I'm actually going to use the 180 turn in place animations. So we can simply grab the bool, use turn 180 animation, plug in the result over here, and make sure we hook it up to both of the branches. So this will determine if we're using our turn in place 180 or turn in place 90 animation. Okay, so that's the top part of the branch. So now we want to go back to the beginning over here where we check if we're turning left or right or not. And over here for the full spin, we're actually going to perform our turn animation. So the first thing we want to do is grab a branch in here, plug it in, and we're going to check a curve value. So if we set one of these bools to true, the animation will start playing. We're going to get to that later in a state machine. So over here, we want to get a curve value. So click in an empty spot, look for get curve value. And for this, we want to get our turn yaw weight. So if we look at the actual animation over here, turn left, for example. So we have two curves in here, the yaw weight, and this is actually set from 1 to 0. So if it's 1, we're actually applying the turning, and as soon as it's set to 0, there's no actual turning in the animation anymore. So the turning part is done. And then we have the remaining turn yaw curve. We're going to use that one as well. And this is mapped to the actual degrees that are left in the turn animation. So we're simply getting these values from the actual animation that's currently playing. So inside here, in the get curve value, we want to put in the name of this curve. So let's just right click and we can do copy selected curve name and then paste it over here. If our turn yaw weight is equal to 1, so let's drag off here, do equal to, and type in 1 and hook it up to a bool over here, then we want to continue. So this is pretty important that you add this node. If you don't add it, then the actual blending in and out of the animation will mess up the values that we're working with. So make sure this is actually in place. And if you're using your own turn in place animations and you're adding the curves yourself, make sure you also have a curve for the weight in there. So for the true pin, we can continue and then look for a sequence again. So we're going to use a sequence in here. And the first thing that we're going to do over here, we only want to do it one time. So we're going to drag off here and look for a do once node. So keep in mind, we're using our update animation event over here. So this fires every update of the animation blueprint. So this node will make sure that what's behind here will only execute once. And what we want to do in here is set our current yaw. So we're going to drag in a setter for the current yaw. And we can set it to the actor rotation. So we're going to drag in our character and from here get the actor rotation. And we want the yaw, so we're going to split the struct pin and simply plug in the yaw over here. And we also want to get our target yaw. So we're going to grab a setter for the target yaw as well and plug it in. And for this one, we can simply grab the replicated variable from the character. So we're going to drag off the character again and get our character character aim yaw. Character. So over here. And we can hook it up directly because this is already the yaw. So if we have the current and the target set up, we can go back to the sequence. And then for the second pin, we're actually going to apply the rotation. So from here, we're going to look for the set actor rotation node. And that doesn't work. So we actually need to grab an actor in here, drag off the actor, and then do set actor rotation. So this node, and we're going to hook it up to the sequence over here. And for the rotation, we're going to use the ease node. So let's drag off here and look for ease. So this is a node that has interpolation integrated. And in here, we can plug in our values that we need. So first of all, the rotators over here. Let's drag off and make a rotator. So this is our current yaw, and we want to drag in our current yaw for the Z value. and do the same thing for the target rotation. So again, make a rotator, and this time we're going to plug in our target yaw for the Z value. And then we need to get our curve value from the animation again to determine the correct alpha over here. So we're going to go to an empty spot and look for a get curve value again. So this time we want to get the remaining turn yaw curve. So let's copy the selected name and paste it in here. So from the remaining turn yaw, we want to get the absolute value. So look for absolute. So if we look at right, these are mapped from 90 to 0. And if we look at left, these are mapped from 0 to -90. So we want to make sure that we get an absolute value to work with. And then we also want to get the correct value. So we are either using 180 or 90 animations. So we need to grab a select node and make sure that we grab the correct base value. So we're going to drag off the absolute and do a subtract. We want to move this one to the lower pin. And then for the upper one, we're going to drag off and do select float. Like so. For the bool, we can plug in our use turn 80 animation boolean. And then if this is true, our default value is going to be 180. And if this is false, our default value is going to be 90. Okay, so we are subtracting that from the curve value, and then we want to map it. So we're going to drag off here and look for a map ranged. And then we can use the unclamped one, that should be fine. So for the in range, we're going to use 0 till the maximum rotation. So again, for the B pin, we need to grab the result of our select float. So that can be either 90 or 180 degrees. And then we're going to map it to a range from 0 to 1. So we can plug it into the actual alpha of the ease node over here. So for the out range, A is going to be 0 and B is going to be 1. And the return value is going to be plugged into the alpha over here. So that should apply the correct amount of rotation. And then all we need to do is stop the actual animation once we reached the correct rotation. So after the set actor rotation, we're going to grab a branch, plug it in here. And we're simply going to grab our character rotation. So let's grab our guard character, and from here get the actor rotation. So we can split our actor rotation over here and simply compare the yaw to our target yaw. So I'm going to drag off the yaw and I'm going to do equal, but this time I want to grab a nearly equal for a float. So it doesn't have to match exactly 100%, but we're going to give it a little bit of tolerance. And I'm actually going to set the tolerance to 2. So we're going to have a tolerance of 2 degrees, and that's mainly for the 180 turn in place animations. So with this plugged in, we want to actually compare it to our target yaw. So we're going to grab the target yaw and plug that into the B pin. And if this is true, then we want to stop playing our turn in place animations. So then we're going to grab is turning left and is turning right and set both of them back to false. And we also want to make sure that we grab our yaw delta and reset this one back to 0 over here as well. Okay, so that should actually be the part that makes our character rotate according to the values in the actual turn in place animation curve. So now that we have all of this stuff set up, we can finally go to the animation graph and start setting up that graph. Let's dive into the animation graph, and we're going to start by making a state machine for the locomotion and the turn in place animations. So let's right click in an empty spot and look for state machine and simply select this one. If you double click it, it will open, and in here we can set it up. So we're going to drag off the entry, and first we're going to add a state. The first state is going to be idle. So simply type idle. And that's good to go. We want to drag off the idle state and add a second state. And this is going to be movement. Now let's make sure that we set up the transition rules right away, so it's a little bit less confusing. So for the transition from idle to movement, we can simply double click it and make sure that our speed is greater than 0. So we can drag off the speed variable, drag off here and do greater than, and plug it into the result. And then we also want to be able to transition back to idle. So we can drag an arrow back to the idle state, and then it will have this new transition rule appear. So we're going to set up the second transition rule in here as well. And we can go back to idle if our speed is 0. So we can drag in the speed variable and simply compare it if it's equal to 0 and plug it into the transition. So that's the first state. Then we can set up the turning states. So we can drag off the idle over here, add another state, and this is going to be turning left. And as I mentioned, we want to do the transition first, and this is going to be pretty simple. So over here, we can simply enter the transition and plug in our isTurningLeft boolean. And that means we can enter the transition. So we also want to be able to transit back to idle. So let's grab a second transition back. And we want to actually set up the transition rule for this one. And we can go back if we're not turning left and not turning right. So make sure we grab both of them. Let's grab a not bool, hook it up to both of them. And let's grab an end node and hook it up as well. So that's our condition for returning from turning to idle. Then we can also go from turning left to movement. So let's drag an arrow to movement, and that can actually happen if our speed over here is greater than 0. So make sure the transition rule pops up. You can move the screen around a little if it's a little buggy, and then automatically it will pop up. So double click the transition rule, and this can be if speed is greater than 0. And hook it up. And now we need to do the same thing for the turning right. So we're going to drag off idle again, add a new state, and this is going to be turning right. So we can enter this state if our isTurningRight bool is true. So we can simply plug that in over here. For the transition back to idle, let's create it. And this time we can transit if we're not turning left or right. So we can just copy the rule from the left one and paste it over here in the right one. Not turning left, not turning right. Again, we can go from turning right to movement. So let's create a transition here as well. And this transition can happen if our speed is greater than 0. And plug it in. And then go back, and the last thing we want to do is make a connection between turning left and right, so we can also swap between those immediately. So if we simply drag in through transitions over here, so going from right to left simply means that our isTurningRight bool is true, so we can plug that in over here. And for the other one, that means our isTurningLeft bool is true at this point, and plug it in over here. So this is the state machine with the actual rules, and now we need to set up the actual animations in here. So let's double click the idle state, and for this one we're simply going to hook up our rifle idle. So let's look for rifle idle hip, plug it in over here, and we actually want to make sure that this is set to looping. So let's go to the side over here and set the animation to loop. Then for the movement state, we can double click it, and we want to use our blend space. So we want to use the blend space jog that's already in here, drag it in, plug it into the result, and we need to feed in our direction and our speed variable. So we can simply hook them up like so. And then for the turning left and turning right ones, so let's do turning left first. The first thing we need to do in here is grab a BlendSpaces by bool. So look for blend bool. And in here we can hook up our use turn 180 animation. So if we want to use turn 180, we want to grab our turn left 180. So let's look for that one over here. Turn left 180, plug it in. And for this one, we want to make sure that it's not set to looping. So do not enable looping. And then we're going to use turn left 90 if the bool is false. Like so. So I'm going to copy these nodes. And then we can go to the turn right and do the same thing. So I'm going to paste in the blend by bool. And this time we want to use turn right 180. And if it's false, we're going to use turn right 90. Okay, so that should be the entire state machine. So we can compile and save it and go back to our animation graph to set this one up. So this is not going to be the final setup, but we need something to start with. So we're going to grab our state machine over here, and from the state machine, we're going to grab a layered blend per bone. So this will make sure that we can layer our hip or iron sight animation on top of our movement animations. So with the layered blend per bone selected, we want to go to the right side over here to the layer setup, expand it till you get the little plus sign, and we want to add 3 branch filters. So let's expand all 3 of them. And in here, we simply need to add bone names where we want to apply this blend. So we're going to set the thigh left bone, and then the bone depth is going to be -1. And for the second one, we're going to set the thigh right bone, and the bone depth is going to be -1 again. And the third one is going to be the spine _01 bone, and the blend depth over here is going to be 3. Then we 3, and then we also want to make sure that over here we enable mesh space rotation blend. So enable this pin over here. This simply refers to bones in the skeleton over here, and this will determine where the animations will blend that we plug in. So if we are back in our animation graph for the layered blend per bone over here for the blend pose, again we want to grab a blend by bool. And this time we want to know if we are aiming or not. So we don't have that boolean yet, so we're going to drag off the active value, promote it to a variable, and simply call this isAiming. Like so. And then we can plug in our idle animations. So look for idle rifle. And then over here we have the idle rifle iron sights. So we're going to plug this one into the true pin if we're aiming, and idle rifle hip if we're not aiming. Plug those in over here. For both of them, we're going to set them to loop animation, and that should be good. So after the layered blend per bone, we're going to grab another blend by bool. So let's drag in a blend by bool. And this one is for crouching. So we don't have the variable yet. So we're going to drag off the active value, promote it to a variable. And this is going to be isCrouching. So this actually needs to go into the false pin. So this is if we're not crouching. And then if we are crouching, we want to use our crouching BlendSpaces. And we also want to know if we're aiming. So we're going to grab our blend by bool aiming, paste it over here, plug the result into the blend by bool crouching. So if we are aiming, we want to grab our blend space for crouching with the iron sights and plug that into the true pin. And if we're not aiming, we're simply going to grab our blend space crouch walk and plug that into the false pin. And in here we can plug in our direction and speed variables to feed the blend spaces. Nope. Like so. Okay, so that's the first part. And then we want to have a little place where we can apply our fire animations. So I'm going to drag off here and I'm going to look for apply mesh space additive. For the additive animation, we want to grab a blend by bool again for our isAiming. So let's copy and paste this one over here. We're going to plug the result into the additive. And over here we can simply plug in our fire animations. So look for the fire, and we have the fire rifle hip. So if we're not aiming, that's false pose. And then we have fire rifle iron sights. If we are aiming, that's the true pose. For both of these, I'm going to select them and make sure we have loop animation enabled, like so. And then we can drive the alpha over here by actually using a boolean. So we're going to create another boolean and call this isFiring. And then we can simply drag it in and drag it on top of the alpha. So if the bool is true, the alpha is 0. And if the if the bool is true, the alpha is 1. And if it's false, the alpha is 0. So over here, we're applying our fire animations. Then we want to apply our AimOffset. So let's go to the asset browser again and simply drag in our AimOffset guard hip. Plug it in over here. So for this one, we need to feed in our character aim yaw and our character aim pitch, like so. That's good to go. And then for this part, we're actually done. So we're going to expand this animation blueprint later in the series. But for now, we have a basic setup where we can work with. So this should actually work. If you compile it, there shouldn't be any errors. And well, we don't need to test it in here. We're going to test it in-game in a little bit. So yeah, animation blueprint done. Let's move on to setting it up in our character blueprint. So let's open our blueprint card and we're going to set up the components first. So let's select the character mesh, and for this one we want to select our mannequin mesh. So the UE4 mannequin from the starter animation starter pack. So make sure you grab the correct one over here. For the location, that's going to be -90, and the rotation on the Z-axis is going to be -90 as well. Then for the animation blueprint over here, the Anim class, we can select our animation blueprint card. So simply hook that one up. And then all we need to do is set up a few things in our character movement component. So select the character movement component. I'm going to set the maximum walk speed over here to 270 speed. And then the maximum speed crouched is going to be 150. Then we want to go down a bunch to the rotation settings. So over here, rotation rate. We're going to set the rotation rate for the Z-axis to 200. And then we want to make sure that we enable the use. Let me double check. I think we need to enable orient rotation to movement, but my note says otherwise. So I'm checking my example project. Yeah, we need to enable orient rotation to movement. So this one. Rotation rate 200, enable this bool, and then go to the class defaults of the character. And if we scroll down a bunch in here, we actually end up at the pawn settings over here. So pawn, and this has use controller rotation yaw enabled. We want to make sure that we disable this one on the class defaults of the character. Okay, those should be all the settings that we need. And this should actually work. So we might want to test it quickly, and we need a navigation mesh in our level to do so. So let's quickly open a viewport. Like so. And for the navigation mesh, we're going to place an actor that's called the NavMeshBounds volume. So look for NavMesh and simply drag it into your level. So you want to make sure that this NavMesh covers your entire level. So on the right side for the details panel, we can set the size. It's going to be 3000 by 3500. And then for the Z, I'm going to increase it a little bit, so make it 300. And then let's make sure it's actually centered above the level. So it actually covers the entire level, and then from the side it also covers the top of all of the stuff that we can walk on. So now if we go to perspective and hit the P on our keyboard from the word perspective or path, then it will show the green areas, and that's where an AI character can walk. So make sure you have the navigation mesh in place and that the highlighted green areas show up properly. So with a navigation mesh in place, we can do a quick test of our character. And we actually need to place the character in the level, obviously. So let's go back to the viewport and simply drag one into our level over here. So it's facing away from me. Well, let's rotate it towards the character. Doesn't really matter. Okay. So first of all, let's check the movement. If we go into our guard character on begin play, we can simply add a random movement. So I'm gonna add a small delay in here. Let's wait for 2 seconds, for example. And then I'm gonna look for an AI move to node. And the pawn is going to be this character. So we can drag off and plug in a reference to ourself. And the location we want to move to, I'm simply going to grab a random location. So drag off the destination and look for a random point in navigationable radius. Close. Random reachable point in radius. So this one. And then we can simply specify a radius. So let's call this 400 units, for example. And the origin is going to be the get actor location of this character. So get actor location. Plug that in here. So this will simply order a random move to the player. The AI. And if we want, we can loop it back to the duration. So if it reaches the target location, it will start moving again to a new location. So compile and save, hit play. And now we should have a character that actually is moving around. So that seems to be working. And you can see the rotation rate, so it's not actually flipping if it's moving into another direction, but it's smoothly rotating. So that part is working. And we can also go into our character, and if we disconnect the movement stuff and simply set focus to a player, we can test the aim offset. So if we want to do that, we need to get an AI controller. So let's move this stuff out of the way. Right click and get an AI controller. So we want to get it from this actor, so plug in a reference to ourselves. And from the AI controller, we can drag off and do set focus. So we need to set the focus to an actual actor. So let's grab a short delay in here to make sure that our player character spawned. And then we can simply right click and get an actor from class. Oh, get actor off class. Okay, so this one. And we can plug in our third person character. So look for third person character. And the return value is the new focus. So now if we hit play, then we should see our aim offset working. So right now, if I'm moving, the turn in place animation should kick in. And the aim offset should also be working. So it's not actually working. Let's see what's wrong. So if I move to the left side over here, it is working, but it only works once. Okay, so I'm going to check out what went wrong and I'll be back in a sec. Okay, this is not too bad. I forgot to hook up a 1 pin in the animation blueprint. So let's open up the animation blueprint inside of the event graph. So we have our do once node and we need to make sure that we reset it after our turn in place animation is done, so we can start the whole process over again. So where do we need to hook it up? We actually have the sequence node over here that has the empty pin. So after the check for the turn in place animations, if both of them are not playing, then we can grab the second pin from the sequence over here and simply hook it up to the reset node of the do once. So this will make sure that we can actually do more than one turn in place animation. So now we should be good to go if everything is saved. So if we hit play and we have the set focus node still hooked up in our AI character, so now it will follow the rotation of the player character, both with the aim offset on the hands and the turn in place animations. So you can see that part is actually kind of working. So finally, that was a pretty long episode, but we have the basics set up. This is not the most exciting stuff, but now we can actually start working on the cooler stuff. So yeah, we needed to get this out of the way. I decided to just make it one episode. It's probably pretty long, but well. So I hope you enjoyed it. If you did, please consider leaving a like, and I'll be back soon with part 2 of the video, where we're going to be taking a look at setting up the weapons. So thanks for watching. Talk to you later, guys and girls. Bye bye.